So in the ICMP, if I look at here, out of 9,851 packets, the displayed value is 21. So only the 21 ICMP conversation happened. So 27. So what if, example, I want to look at all the traffic, but I don't want TCP traffic. I'm not interested in TCP traffic. Somebody is saying, oh, I want to ignore the TCP traffic because there is something problem with other protocol, my DNS, maybe my ICMP, whatever protocol, but I don't want the TCP packet. How to do that? So you have to give exclamation and TCP. If you give that, you're going to see all the protocols except TCP. You see all DNS, ARP packets, your ICMP, right? You see all the protocols, but not TCP. So 1,863 packets except TCP. So all the protocols are included in this 1,863 packets, but no TCP packets. Total, I got 1,863. So now, I don't want ICMP packets. The same filter you have to add. This is also called as not ICMP. Exclamation ICMP. So what is the meaning of it? It's not ICMP. If you give not ICMP, you're not going to look at the ICMP packets here. So 9,830, but not ICMP. It includes all the protocols. So now I'm interested to see, I don't want to see DNS, I don't want to see ICMP. I'm interested to see TCP and all other protocols, but not UDP. So now you cannot see any UDP because I gave exclamation UDP. It means that I want TCP and not UDP. And you see only TCP conversation here. So how many packets is 7,988? Okay, now we got to know how I can filter the TCP, DNS, UDP, and I got an idea about all this. So now let's go for a scenario. Example, you got a problem where you have a network loop. But as I said, with just the CLI and the monitoring application you have, you cannot rule out, or you cannot concretely say it is a network loop or you don't have any problem. But what is the proof, and how do I do that deep analysis and deep dive and find out, okay, there is a network loop, or my network is very clean? So how do you prove that? So to do that, I have a packet capture. That's a lab capture I did. This is a use case to find there is a network loop. So to do that, I have to type TCP first. We all know. So I'm just looking at the TCP conversation now. So here, let me start with from here. So here, if you see, this is source port. And this is destination port. This is HTTPS because HTTPS uses 443. You cannot see all this in your router, right? Maybe in the firewall, you get to know what is the active connection, what is the protocol used, but just with routers and switches. If you have Wireshark, you can see all the port numbers, and what is the protocol used, and your TCP handshake, and even more. We'll see that. So now we got source port number. This is my random generated port number for my PC. This is my private IP address. And this is my public IP address. And this is my public IP. So when I look at this, we discussed about this, right? From the source to the destination, SYN. So from the destination I'll get a SYN ACK back. It means it says that I got your SYN and I'm acknowledging you. So for this SYN ACK, it's going to send a sync again. This is a conversation between source and destination. So now I know from this Wireshark, I have taken out these values. This is my source port number. And what is my destination port number? It is 443. And based on the port number, I know this is HTTPS connection. So here TLS is used. We all know TLS uses HTTPS. It's running on top of that, right? So you see this client hello, cipher exchange, the certificate exchange. This is too deep, but I'm just giving a glimpse of it is using HTTPS and we are using TLS. That's why the handshake, you all see all this information. Only possible with Wireshark. So I get to know about all these details. So now how do I find it's a problem with the network? How do I figure out that? Okay, so for that, first we have to see the basics. So I see SYN ACK. So it means that my connection establishment is successful. Agree? Yes. My connection established. So what is the problem now? My connection is established, but how do I find out there is a network problem? If you drill down, you can see the errors. Okay, what is the first error I see? It says retransmission. So now we have to look closer. So who is sending this? So this is the destination port. From the random port number, I have figured out that, okay, I know this is client. And from the source port, this is HTTPS, only the server uses it. So I know this is server port. I know this is server. If you drill down even more, so you see is that retransmission TCP segment data. And if you drill down this sequence and acknowledgement analysis, there is an analysis flag set here. It says this frame is a suspected retransmission. So why retransmission happens? It says, I didn't get this packet. Can you retransmit back again? Send it back one more time because I didn't receive it. So here the retransmission happened. You can find that under the TCP analysis flag, and expert info will give you this detail. So here the retransmission happened. And who is doing this retransmission? I have to find out, is it a problem with the client or server? But from this, I cannot figure out. So I have to do a deep packet analysis. So one retransmission happened that from the server to the client. So if I do a drill down, so I have to look at any other errors, TCP errors. Okay. Can you see this? It says TCP out of order. What is the meaning of TCP out of order? Example. So this is my source. This is my destination. We all know this is not a one-to-one communication. There are service providers in the middle who gives an internet connection for me. So I have a redundant connection. That's my ideology to say here. So I have a redundant connection to it from my source to destination. So the TCP, it says it's out of order. What is the meaning of it? So if my source and destination is communicating in one single path, if the communication is happening only between these two paths, if it is going across this router 4 hops away, and if I'm reaching this destination, I won't see this out of order. The TCP out of order, what generally it says, so when I send a packet from source to destination, it goes to this primary path, router 1, router 2, and router 3, and it reaches a destination here. So when it comes back, it's actually coming back with router 6, router 5, and router 4. So this is taking this path instead of this path. So this is called a route. This is a loop in a network, right? So I got two paths. This is not good. I should have the bidirection should happen in one single linear path. It should not happen like this. Then there is a loop. Because of this loop, the network is completely confused and I don't know where to send back this request back. So for the first time, it's going to send in the primary path, A to B. It's going through router 1, 2, and 3. But when it is coming back, it is coming through R6, R5, and R4. It's taking a longest path instead of coming back in the same. But this is for a demonstration. I have given only 4 routers. There can be hundreds of routers in the middle. We all know that the ISP is all interconnected. They do this BGP pairing and they do all this. And this is not guaranteed that I'm getting a reply back from the same place. So where exactly this has happened? So if I look at that, if you see that first retransmission, when we looked in the very first place, when we saw this retransmission, it is from the destination, from the server. If you see the TCP out of order, it's been generated only on the destination, that's the server. So it means that my problem is with the server, not with the client. If you see, all this out of order has been sent from this. So about how do I filter out only this? I have to go to conversation filter, or you have to right click and you have to go to conversation filter and you have to do TCP. And you see only this conversation. You got 10 and 20 TCP conversations. But I am interested in one single conversation. And you can see this is the destination, this is a source, this is a server, and it says TCP out of order. If you see the acknowledgement number and sequence number, they are all unique. So here is a network loop. How this is possible? Only through Wireshark. You cannot do this with your appliances. You cannot with CLI. You do not have this kind of deep insights about what exactly happened between this TCP IP conversation. So now we found, okay, what is the meaning of TCP out of order? It means that there is a loop in a network. So what are the other key things we have to see here? See, this is all non-routed packets. I can definitely say this is time to live all with 64. So we all know this is the standard. They say it's a TTL value. For Unix, it is 64. 64 is 64 hops. And for Cisco routers, it is 255. And for Windows, I believe it should be 255. So why TTL is so important here? Do I really concern about TTL? Definitely. Because every hop that will be decremented. Example, if my packet is going from R1 to R3, so for every hop, the TTL value will be decremented by 1. So here, if you see, these packets are not routed at all. If you see the sequence number, it's going to be the same. So here, no routing happened here. There is a problem with the connection. That's what I mean to say. So in my whole conversation between source and destination, there is a place where I'm not getting a response back. So why? Because it's going in a 2 different path. There is a routing loop. And if you actually see here, this is all taking 2 seconds. 2 seconds in a network is a high latency. It's all happening in milliseconds. And the routing is not happening. So I can confidently say it is a problem. And it is a problem with the destination. Right? For this request, I'm not getting a response back at all from the destination. So it means that my packets are not routed. It's not moving forward. It got stuck in one place because of this routing loop. At times it works, at times it is not. So we say this is an intermittent issue, right? And there is a slowness in the network. The network path is not, properly optimized or designed. So I have to look at routing. So from here, you can take it, you can leverage your troubleshooting further. So now I found there is a loop, but how do I find that? So I'll do a trace route. from my command prompt to the destination, example 8.8.8. So it's going to show me two different paths. Example, if I want to reach 8.8.1, example, I am going to 192.168.1.1, my modem router. Then it goes to public, example, 113.4.5.6, 113.4.5.8, and then I reach 8.8.8. But when I do the same thing in the destination, example, this is happening inside your network. I mean, this is inside your enterprise network. This is not in the cloud, I'm saying, but because the cloud they have a load balancing, and you may see a different path. But I'm talking about only your branch office and remote office connection, something like this. Only between your branch office and your remote office, a connection, something like this. This is all branch office, and this is your headquarters example. So I'm just talking about the communication between your branch office and the headquarters. And if you do a trace routing, you will get a different response. Here it is taking the IP address, whatever you see here, but when the reply comes back, you see a different value. Example, you see here 114.4.5.8, but it's again reaches 8.8.8, but that is not expected. If your path is optimized, you have to get a reply back in the same path. It has to take the same path. Then it is a routing loop, and definitely there will be a latency, and there is a performance issue. So you have to figure out this. How I come to know about all this? Only because of Wireshark. Wireshark gives the complete insight about the issue. You cannot do that only with router CLI. You can do a trace route, but how can you find this TCP out of order and TCP retransmission and acknowledgement numbers? So all this information is only available in the Wireshark, and you can make use of this tool. And so many people, they use this as the architects, they use this tool to figure out the problem. If there is a problem continuously and we cannot figure out, so they come in and they do all this packet analysis, and they'll figure out it's a problem with the network, or it's a problem with the application, it's a problem with the server. So now I say this is a server because the server is keep retransmitting here, but anyway, my path is not optimized. So it's my problem. So once I fix this problem, still I encounter this problem, then there is a problem with the server. So now let's see TCP retransmissions. Let me take out this filter. So I want to see only retransmissions. So conversation filter, TCP. If I drill down, you can see the fast retransmissions, duplicate acknowledgements. Yep. So here is a scenario. So now if there is a problem with the client, now the server is fine. Now there is a problem with the client. So how do I find that? So here you see the TCP duplicate acknowledgements. Why it is a duplicate acknowledgement happens? Let me once again do this. So this is again source. And this is destination. Sorry for that. Let me delete this. This is my source and this is my destination. The same way, my three-way handshake is successful. Yeah, my connection established. This is the phase where your connection is established. What is the next step? It's a payload. It's your actual data. So here I see a lot of TCP duplicate acknowledgement along with retransmission. So if you actually see this, see here again, from the time to live, my packets are not routed. So here the actual retransmission happens because it says, see, here I have no connection. It proves I have no connection. It keeps sending duplicate acknowledgement because I don't have network. My network is down. From the source, there is no network connection to the destination. So I have something problem with my network here. So I keep sending this duplicate acknowledgement. And finally, here it happened because congestion, because of latency. See here, no actual payload. It's all your TCP segment length. So my TCP segment length is 0. It means that no data has been transferred across. So it's keep asking me, I did get the packet. Can you send it back again? So it's going to keep on sending the acknowledgement until I get a retransmission back. So this is how you can, rule out your issues. So the very fast way of finding the problem, instead of scratching your head for a long time and you have no clue of where the problem is, with the help of Wireshark and with the proper filters. So I didn't apply any filter on top of this. If I just follow the conversation, TCP conversation, you can see the filter has been auto-populated right back here. So it says this is my source port, right? 61918. And this is my destination port server. And this is a server IP address. And this is a client IP address. So I get to know about all this. Just I have to do is apply filter, conversation filter, and do TCP. And you will get this here right away. With the help of filters, this is very, very minimal amount of finding errors. You will find, you have a lot of errors that you encounter every day, but you have no clue of what exactly happening in the background. But with the help of Wireshark, you will get to know how to rule out this issue. So if you're familiar with Wireshark, then it is a cakewalk for you to find out the problems in your network. So this is all about Wireshark and TCP/IP, and I hope that everybody they got more understanding about TCP/IP and what is TCP out of order, what is retransmission, what is the three-way handshake, and how do I apply filters in Wireshark. So in the real classes, you will get more scenarios, more troubleshooting, more hands-on, and you will go deep about every single protocol. So now we got a glimpse about what is DNS and how this DNS query happening. And if we want to find out why the DNS query, who is not sending a response back for my DNS query, is it a source or destination, or if it is a TLS handshake, where is the problem? Is it a problem with the server or client? Is it a problem with the certificate? So you will get to know about all that. You will get the complete insight and you can decode everything with the help of Wireshark. So this is all about this Wireshark webinar. And I hope that everybody would understand and they got a solid understanding, at least a basic solid understanding about TCP and what is the use of Wireshark and how you can filter the packets using Wireshark. So now I'm going to unmute everyone and you can ask your questions.
Hello.
Yeah, hello.
So my question is, suppose the communication like that's SSL handset.
Yeah.
Like source IP is my like 10.40.40.10 server.
Okay.
And destination my is 172.20.20.10.
Okay.
And how we can check the SSL handset is complete or not complete?
Okay, so example, if you look at here, let me drill out this. Okay, let me put this as a TCP. Okay, so see, if you actually see this is client hello, and this
Yeah.
is server hello.
Mhm.
So if I get a server hello, server is responding back, right? So if I get a server hello, the connection
Okay.
establishment is successful. And then again, once the client and server hello happens, here exactly your security handshake happens. And here, if you see your actual data, it's been sent it across. Here, its actual payload happens here. But the client hello and server hello should be successful. Only then the security handshake happens, and then your actual data payload will be sent from the source to destination.
Okay. And what is the next parameter we can check? SSL handshake.
No,
Suppose
if
one packet you can open,
Mhm.
like we normally we have checked source IP, destination IP, protocol number,
Yeah,
three-way handshake, TCP sync.
yeah.
For SSL, what is the next? What is the extra parameter we can check?
No. If what I'm saying is, see, if your client for your client hello, you got your server hello, it means that you got the server hello back. It means that the connection is successful. Then it's exchanging the security. No, the security handshake happens here. So if this cyberspec happens here, your actual data transfer is happening. So that's it. If you are at this place, then your connection is established successfully. There is no problem with your communication here. If I'm not getting a server hello, then it is a problem with the server.
Okay.
Right. So but here I got the server hello, but we have to do a use case where we have to, you have to make some problem with your server, and the server should not respond back. You should turn off your server, or you should give a wrong IP assignment, something like that. So you cannot get a server hello back. Then you can find out it's a problem if the server is not responding. Maybe the server is down, or maybe something problem with the server certificates. Example, if you get server hello and this change cipher, there is a problem with this change cipher. If there is an error here, then you can say it's a problem. Who is doing that? So where the change cipher error happening? Is it on the server or client? So it depends on the scenario. You have to replicate the issue. Only then we can figure out it's a problem with a client or server.
Okay.